This is plasma in a bottle. I have my Tesla coil inside a Faraday cage with the wire going down to my lightning in a bottle piece. So I'm going to turn the light off and plug it in, and you'll get to see the awesome power of lightning in a bottle. Okay, here is a piece of dichroic glass. Dichroic glass is basically gold that has been blown onto a piece of glass in a vacuum chamber. I'm not exactly sure how they do it, but you can look it up probably on the internet. Anyways, it creates different colors by changing the light that hits it. This piece was originally purple after it fired. It looks purple right now, but when you look at it straight, it kind of wants to be green. It's not too nice of a color, but anyways. It has a sheet of clear fused on top of it. I have it outside of sparking distance of my Tesla coil, but it is still in the energy field inside my Faraday cage to absorb the energy field from disrupting other stuff. So yes, we are going to see what the energy field does to dichroic glass. I'm going to turn the light off so you guys can see the electricity. Here we go. Also, in case there's any plasma. Here we go. Okay, so it appears nothing happened. Let's see what happens when we bring it within sparking distance. Alright, here we go. Piece of dichroic within sparking distance. It's probably going to want to arc to it right away. Here we go. And let's see what happened to it. Well, really, it appears like nothing. It's a little warm. But still looks fine to me. I don't see any damage from sparks. Let's see, any dichroic. No, still looks fine. Interesting. Here's our other piece of dichroic. Yes, it's a very shiny. There's my plasma waffle. I'm just gonna put it on for fun. But yep, here is my bigger piece of it. See what happens to it. Alright, I'm going to turn off the light and turn it on. I will bring the discharge probe near it like last time. Here we go! Okay, I did that one fast just because I wanted to see if it made any lines in the dichroic. It appears dichroic's unfazed. Definitely conducted, though. As you can see, it wanted to go over it. I'm going to fire it up again and bring the discharge probe near it. Okay, I turned it off because the wind's messing it up. The wind moved it. Dichroic with discharge probe, here we go. Let's check it out. Let's see what it looks like. It's slightly warm, just like last time. But close inspection reveals nothing. I don't see anything. Not really changed. Just looks the same. All shiny, but it's definitely conductive. That is a cool part. Really cool part. You could probably make a plasma waffle with dichroic. Plasma globe. Here we go. I'm going to use my fingers. Don't worry, I'll be fine. Hello everybody, this is a new piece of glass I have to test. Basically it's, there's a bubble, or tried to make a bubble. The middle of the bubble fell in. There's air around it. Here, let me show you. There's air around here. Right here there's a dotted line of gold pin. And then there's two electrodes in it. Basically just made a square of rectangles of glass, and then I have a piece of flat glass and a square around it, and another piece of flat glass on top. And on the bottom piece of glass is where the electrodes and the gold pin is. I have it at a distance where the electrical sparks should not touch it. It'll just be inside the energy field. So I'm going to turn the light off, and you'll see what happens. At first, it's not going to be grounded, and then I'm going to take my grounding rod right here and ground out this lead right here and see if that makes a difference. Alright, here we go. Alright, so we have a breakout point. This piece of glass where you're testing is within sparking distance from the Tesla coil. What I mean is the sparks are going to jump from the breakout point to the device. It probably is not going to do much, but shoot sparks. If I bring a grounding rod near it, it might change it a little bit. I'm going to turn off the light. Let's see what happens. Here we go. Alright, so that was neat. As you can see, it wanted to go through the air, not the metal. I guess I didn't space out the dots enough. Here we go. Well, I thought that was neat. Alright, this time we have the one terminal grounded out. We're going to send electricity through it and see what happens. Here we go. Basically, it was just a lot more brighter. Hello, everybody. Inside that little Miniatronics Menduino is an Arduino. It's not a Menduino. It's it's like an Arduino Nano, I think. But it's made by. It's not made by Arduino. I got it from Fry's for 20 bucks. It's a nice cheap one. As you can see, it's just got the Blink sketch uploaded. That LED you see there is connected to pin 13. And that little metal box, since the Arduino is insulated from that metal box, acts like a Faraday cage. As you can see, I have my Tesla coil inside a big Faraday cage. As some may know, it's my Tesla coil outputs around 250,000 volts at around 500 hertz. And I have a key switch, you know, turn it on and stuff. But I am going to turn it on, and you will see that the Arduino will not stop working. I have actually shocked this Arduino's case with the electricity, and it has not done anything. Well, I am going to turn the light off and plug it in. As you can see there, the fluorescent light tube is on. Sparks of electricity are coming out, and there is energy around this, but the Arduino still continues to work. Blinking on for 1 second and off for another second. The electricity does not stop it. Tesladuino on top of Tesla coil.